All right, welcome back. Today, we're going to put on our detective hats and solve a little chemical mystery. We're going to take a simple experiment, look at the results, and figure out exactly what happened, and more importantly, how well it actually went. So let's jump right in and look at the evidence.
Okay, so here are the facts of the case. On one hand, we started our experiment with a very specific amount of this blue crystal, copper sulfate. And then, after the reaction, poof, we're left with this tiny little pile of a black powder, copper oxide. I mean, we lost more than 3/4 of the mass. So where did it all go?
And that right there is our central question. Does this result mean something went terribly wrong? Was this whole thing a total failure? Or maybe a smashing success? Or is it somewhere in between? To answer that, we've got to dig a little deeper into the process itself.
So to get to the bottom of this mystery, our very first step is to understand the journey our chemicals took. We need to follow the reaction pathway from the very beginning to the very end. It turns out this wasn't just one simple change. Our experiment was actually a two-step process. First, our copper sulfate turned into something called copper hydroxide, and then we heated that stuff up, which broke it down into our final black powder copper oxide. The key takeaway here is that the copper atom didn't just teleport, it had to go on a whole journey to get to its final form.
Okay, so we know what happened. But to really judge our results, we need a baseline, right? We need to know what a perfect, absolutely flawless, 100% successful experiment would have looked like. We need the perfect recipe.
And you know what? In chemistry, that perfect outcome actually has a name: theoretical yield. Think of it like this. It's the absolute maximum amount of product you could ever hope to make from what you started with. It's the number you'd get if every single atom did exactly what it was supposed to, with zero waste, zero mistakes along the way. Perfection.
And here's the beautiful, simple part of our recipe. Even with that two-step reaction, the relationship between the copper we started with and the copper we ended with is super straightforward. For every 1 unit, or mole, as we say in chemistry, of copper sulfate we put in, we should, ideally, get exactly 1 mole of copper oxide out. That 1-to-1 ratio, that's the key to this whole thing.
Okay, so now that we have our blueprint, that simple 1-to-1 ratio, it's time to crunch some numbers. Let's calculate exactly what that ideal, perfect outcome should have been in grams.
Now, to do that, we need these tools right here. These are the molar masses. You can think of them as our universal translators. They let us convert the language of grams, what we can actually weigh on a scale in the lab, into the language of moles, which is how the chemical recipe is written. So, the calculation itself is a pretty simple 3-step journey. First, we're going to take the grams we started with and turn them into moles. Then, we apply that super important 1-to-1 ratio. And finally, we just convert that result right back in the grams to get our answer. Simple as that.
And this is what it looks like when you put it all together. Now don't worry about grabbing a calculator or anything, but you can see our 3 steps laid out right here. Grams to moles, our 1-to-1 conversion in the middle, and then moles back to grams at the end.
And the answer is 0.199 grams. This is huge. What this number tells us is that in a perfect world, starting with what we had, the absolute most copper oxide we could have possibly made is 0.199 grams. That number, that's our theoretical yield.
Okay, we have our magic number. We know what should have happened. So it is time for a reality check. Let's compare our perfect ideal outcome to what we actually got in the lab.
Wow, okay, this chart really puts it into perspective, doesn't it? On the left, you've got this towering bar. That's our ideal theoretical yield at 0.199 grams. And then over on the right, you see our much shorter bar. That's our real-world result of just 0.080 grams. So yeah, we were definitely not perfect. But the real question is, just how efficient were we?
Well, to measure that efficiency, we use a concept called percent yield. It's a really simple but incredibly powerful idea. It's basically the grade we give our experiment. It tells us, as a percentage, how much of the maximum possible stuff we actually managed to make and collect.
All right, it's time. Let's calculate that final score. Let's officially grade our experiment and finally answer that big question we started with. Was it a success or a failure?
And the formula for this, it's about as straightforward as it gets. You just take the amount you actually got, divide it by the amount you theoretically should have gotten, and then multiply by 100 to turn it into a percentage. So when we plug our numbers into that simple formula, we get a percent yield of 40.1%, and this chart here shows it perfectly. We successfully made and recovered about 40% of the maximum possible product. So where'd the other 60% go? Well, it was lost somewhere along that two-step journey.
Maybe some of the starting material didn't react, or maybe some product got stuck on the filter paper. It's the messy reality of chemistry.
Okay, so let's wrap up our investigation here. The theoretical yield, the perfect outcome, was 0.199 grams. What we actually got was 0.080 grams. That gives us a final score, our percent yield, of 40.1%. So, the verdict? You know what, this is actually a pretty realistic outcome for a classroom lab. It's not perfect by any means, but it is absolutely not a total failure. It's just reality.
And that leaves us with one last big idea to chew on. We've seen that getting even a 40% yield in a simple two-step lab experiment has its challenges, right? But now, imagine scaling that up. Imagine the product isn't a simple black powder, but a complex, life-saving drug that takes maybe 10 or even 15 different chemical steps to make. Every single one of those steps has its own percent yield, and those losses, they compound, they stack up. The incredible challenge of making affordable medicine for millions of people isn't just about the initial discovery. It's a massive, ongoing battle of percent yield. It's something to think about for sure.